Hi, today I'm going to be doing a presentation over titration labs we did in our introductory chemistry class. My name is Corey Redfield, and the girls that put this PowerPoint together with me are Robinisha Walker, Raven Royal, and Fatimata Bakar. Okay, first I'm going to be talking about antacids. Antacids are used to neutralize stomach acid, produce calcium chloride, water, and carbon dioxide gas. Antacids also prevent the denaturing of proteins, which can prevent stomach ulcers. Many expensive antacids are a mixture of calcium carbonate, flavoring, and the inert binders. Okay, the purpose of the experiment that we did was it allows you to find the concentration of a known amount of unknown acid or base by using another base or acid whose volume you already know. So by slowly adding the known acid or base to the unknown base or acid, it will eventually be neutralized. Once neutralized, you can do some calculations to find the unknown concentration or strength. The next slide is about titrations, and just the definition of it. Titrations is the procedure in which a base is added to an acid until it is neutralized. Neutralization reactions can often be monitored using a pH indicator. For every titration lab, we used a 50 milliliter burette with a 0.10 molarity of hydrogen chloride acid, or HCl. And for the base, we used a 0.10 molarity of sodium hydroxide, or NaOH. We also used a ring stand and a burette clamp. And here we just have some demonstrations for you. This is our burette clamp, and then this is right here, it's the burette, and we have a ring stand right here, and then we have our little Erlenmeyer flask down here. Okay. Our first lab was the Titration 1 lab. In this lab, we used phenolphthalein as a pH indicator. Phenolphthalein is bright in acids and dark pink in bases. When neutral, phenolphthalein is faint pink. Throughout the labs, we have to find the initial and final reading of the burette filled with 0.10 molarity of HCl and 0.10 molarity of NaOH. Then, after data is collected, we have to find the number of HCl and NaOH moles added to each flask. The Titration 2 lab. Very similar to the Titration 1 lab, we measured out the HCl and the NaOH. In addition to the first lab, we added calcium carbonate. Once again, we found the number of moles in each solution. This helped us to find how many moles of HCl were neutralized by the CaCO3. Our final lab was the Titration 3 lab, and in this lab, we were comparing name brand antacids to the generic antacids. It was a continuation from titrations 1 and 2, with the addition to the finding the comparison between the two antacids. Here we have a graph for you, and it's showing the name brand, which is the dark blue, and the generic brand, which is the light blue. And here it says these are the comparisons of the grams of antacid used and the comparison of the percent of CaCO3. And you can tell that both graphs are very similar, or their numbers are quite similar. Right here it's slightly over 0.25%. Right here it's right around 0.33%, 0.34%. So they're very similar, and there's not a lot of difference between the two numbers. Our final conclusion was that, based on our data, we have come to the conclusion that we would buy the Walgreens brand because the cost is less. Also, the number of grams and the percent of calcium carbonate, are close to being correlative. And right here in our demonstration, you can see that Tums, which is the dark blue, and the Walgreens brand, which is the light blue. How we did this was we found out the cost for each tablet, and the cost for Tums, it would be right around 0.09 cents per tablet, and the cost for the Walgreens brand would be right above 0.04 cents per tablet. Okay, and that's all that we have today for our titration lab. Thank you for watching our presentation.